Okay, so it's recording on your cloud now. Okay, so again, very good morning, everyone. I hope your day is going good. So I hope you are equally motivated seeing the video. So I'll actually start today. I know some of you are very new, don't know me. First of all, my name is Orkoich, and I practically teach Java here. So let's start. I know some of you might not catch up of what I'm teaching or might not, know what I'm discussing right now. But I'll just ask you, to go along with me. Ask if you have any doubt. Try to figure it out yourself till the point where I'm able to give you a backup. But rest assured, once I give you the backup, you will definitely understand what I'm discussing. Okay. Okay. So I'll just quickly share my screen. Okay. Now, I today want to discuss about methods and method overloading. Okay. So basically, if you remember long back, okay, team, I was discussing with you something called as, objects. Okay. And I told you that, each object that we are dealing with, have two different parts. It has something called as has something, that is the has part, and it does something, so that's the does part. And all these days, if you would have noticed, we are dealing with the has part. Has part was nothing but the properties of an object. Okay. And we were dealing with it using, data types. So I hope till now you have learned everything about data types. You know how to use it, what are the data types when to use, what are the default values and how they are constructed, and everything. But now we should start dealing with the does part of an object. Okay, does part, as you all know, are nothing but the behavior of an object. Okay, and this can be handled using methods in Java. Okay, now very simple. If I just take a, remember object such as a dog object, what are the has things? It was having a name. A dog has a name. A dog has a excuse me, color, a cost. That were the properties of a dog, and I handled it using data types. But a dog has does some behaviors, right? Like it used to bark, it used to sleep, it used to eat, correct? And I was handling the mute methods. But today we'll understand more about it, how method actually works, how it executes at the background. As I've already told you, a good programmer learns how to debug and basically always look towards how it is executing at the background to have a complete control over the program. Now, if you'd mention, I'll just reiterate it for our new, freshers here who have joined today. Excuse me. Every method that we uh, work or create or write has basically four things into it. Okay, the very first thing a method will have is a name. Second thing a method will always have is input. Third thing a method can have or cannot, I mean, it all will have is the body. The fourth thing that a method can have is output. Okay, so these are the four different things a method should always have. Okay, I'll point it out to them once more. First is the name, second is the input, third is the body, and fourth is the output. So simple lame English terms, these are the four things a method should have: a name, a input, a body, or a collection of statements, you can call it as, and fourth is the output. Now, not only that, understanding this is not enough. This is not sufficient. Okay, we are here to talk in technical terms, and hence I'm going to convert this into a technical terminologies. So the name remains the same. It's name after all. Okay, so then there should be a method name. When you talk about input, they're actually called as parameters. Okay, in technical terminologies. Then we have a body. Body is called as body only, or a collection of statements sometime. Okay, and the output in technical terms we call it as return type. Okay, so again, these are the four things we have: name, parameters, body and statements, and return type. Just so you get a clear picture, this is the input, whereas this is the output from a method. Okay, so this is what we technically call it as. Now, based on these four things, okay, the name, the parameter, the body or the statements that it carries, and the return type, there could be four different types of method we can be dealing with. Okay, there's no category, or mainly, I shouldn't be calling it as a type as well. Okay, but just so you understand, I'm calling it as a four different types of a method. Okay, so what are the different types of methods that can be there in Java, let's say today, that we can deal with? Okay, so the very first type of a method that you can deal with is this one. Okay, I'll just create them and then I'll discuss about them. So this is the four different methods, let's say, that we can deal with. The very first one, let's say, okay, a method could have no input and it could give no output. Okay, this is the first method. Second kind of a method is there could be an input to the method. Okay, and there could be no output to the method. This is also a scenario. Now, there could be one more scenario here where there could be no input actually. Okay, but there could be output to the method. And the final one, I hope all of us has already figured out. It could be our input is coming to the method and an output is being given by the method. These are the different kind of different types, you can say. I'll just cover them in a one single slab of different types. Okay, so these are the different type of methods, or four types of methods that we can have. Okay, so we'll see each one with an example so that it sits in our brain, permanently. But before I go there, okay, today I want to give you a note. If you all remember, okay, we'll see one example of each one, so don't be worried about it. What I'm worried about is if you remember the segmentation of JRE. Okay, can anyone tell me in the class or in this complete team what are the different segmentations of JRE?
Code segment, stack,
Yes.
static,
Yes. Last one?
heap.
Exactly.
Heap.
Yeah. So if you all remember, JRE was nothing but if you want to know what is JRE, it is nothing when every application you download from internet, it is sitting on your hard disk. Okay. Now when you start executing it, that application is given a memory space on the RAM, or some memory is allocated for it on the RAM, and it is decided by the operating system. Okay, and that memory which is allocated for the execution of the Java application is called as GRE, Java's runtime environment. Now, GRE is the place where your application is running on the RAM, and that GRE was, as some of you, I guess it was Ashish or someone, or Sumit, maybe, I don't know. I didn't see the member list. So someone in the class correctly point out that, sir, the GRE was divided into four different parts. One was the code segment, other was static stack segment, other was static, and finally we had heap. So these were the four different, segments or the four different parts we had in JRE. We also discussed that static is nothing we're gonna pick up right now. We'll pick up at a later point of time, but we're gonna use code, stack, and heap. Is there a doubt? Okay, so that's the JRE, and there are four different parts to it. Okay, so as we discussed, static will be seeing when we take up the topic static. But yes, code, stack, and heap segment, we already saw how a program executes and what is stored where. Correct. Code segment is the place where the code goes and sit. Stack is a segment where the local and the reference variables are created. Heap is the place where the objects are created. So this much I hope all of us are aware about. But something which I missed out, or which I intentionally did not tell you yet until the method topic was here, is remember in stack, okay, the reference and the local variable just doesn't get created automatically. Okay, for each local or a reference variable which is created, it is created inside an activation record. Okay, now what is the activation record? Remember the heaps, the inside the stack segment, sorry, whenever a method is executing, okay, inside the stack segment, an activation record will be created. I'll be writing this as a note here. Okay, once I write, I'll explain it later. Okay, don't worry. I first give the notes and then I explain it off. So the first note I want you to remember is, remember whenever, okay, a method is called, in other words, when a method is starting to execute, okay, its activation record its activation record is created on the stack segment. Okay, you can call it as activation record, you can call it as a stack, both are correct. Okay, the second most important point to remember, whenever a method or whenever the control exits the method, its activation record is deleted from the stack segment. Okay, so these are the two notes I want you to remember. So whenever you are entering a method or starting to execute or calling a method, its activation record is created on the stack segment, and once the control exits, or in other words, once the execution of that method is finished, okay, the activation record of that particular method will be deleted from the stack segment. Now what does this mean and how does it helps us? Okay, let's see. Okay, I hope this much is clear. Any doubts, any thoughts in your mind? Okay, I'll take the silence as a no. Please take a quick screenshot of this one so that if by mistakenly I erase this, you will still have it as a reference. Don't worry, I'll explain you all the four types of a method, and I'll also explain you what is the activation record, how it works at the background, the memory. Okay, I hope all of you have taken a screenshot. Now, let me go to a very simple program that I've written in the Eclipse. Okay, I'll show you here. This is a very simple and a basic program that I've written. Now, first of all, this is an example, people. Okay, this is an example of no input, no output. Now, how will I show it? It's a later point of time. I'll explain, I'll discuss how it is a no input and no output. But this is a very simple program. If I execute this, the solution is giving me 30. Now let's see how it is coming. First of all, how am I able to achieve 30 as a result? Okay, now for that, let me quickly open this one. That's the same program which you saw. Okay, so that I just want to show you. Okay, this is the one. It's the same program where we are having three different variables, where a and b is having a value of 10 and 20. C is basically adding and storing them and printing them, and I'm creating an object of this class, and basically calling the method inside this class. So this is the same program. Now if you notice, I would like you to see that how the program started its execution. Okay, I'm just considering three segments now: code segment, stack segment, and the heap segment. So once the program starts to execute, the very first thing happens is the complete code comes and sit in the code segment. Okay, now as we all know that operating system is the one who gives the control. So let's assume this is the operating system. Okay, and because it's a heavy weighted software, the execution, the power of execution is with the operating system. So we have to request the operating system to give us the control, and as I've discussed previously, it always gives control to the main method. Okay, now once it gives the control to the main method, now I want you to think about it, what I'm telling. It's a main method. At the end of the day, don't you think the main method is a method we are entering it right now? Okay, so we are starting it, we're calling the main method, and as per my previous note here, if you remember, whenever a method is called, its activation record is created on the stack segment. I'll do the same thing. Because I'm calling the main method, the beginning of the program execution has started. So what I'll do is, I'll go here and I'll create an activation record for main method. So let's say this is the activation record of main method. Just so you know, I'll write it here. Okay. It's the activation record. I'm writing in small a.t of main method. Okay, and the complete code which is present inside the main method will also be present here. Okay, the complete code of 2 lines will be present here. I'm not able to write it, I'm just showing you so that you understand. The complete main method will come, and with proper code will sit in the stack segment. Now the execution of main method will start. Now as you can see, the very first line, okay, let's assume this line here starts to execute. Now when this line here starts to execute, you can see it's having an equal sign, equal operator. Okay, it always tells that you resolve the RHS first and then go to the LHS. So in RHS, the very first keyword here is new. New is nothing but a keyword which activates JVM, that is Java's virtual machine. It will know that, okay, the user has written new, means the user wants me to create an object. Okay, so it will go and create an object over here. Let's assume this is the object that it has created, and as you know, all the objects are created on heap segment. So this is the object it has created. Not only that, whenever he creates an object, he gives the address to it. So let's assume the address for this object in the memory is 4000. Let's assume. Okay, now you did not just tell new, you told a class name here, addition1. So you want to create an object of addition1 class. So come here, you will see the addition1 class. In this, you can see there are some instance variables. Now I am pointing towards specifically them as instance variable because you all know about it. So instance variables are the variables which are inside a class and outside a method. So they are globally present. Okay, so they are accessible throughout the class. So it will create all the instance variables. Okay, and I hope you all remember, as I have taught you yesterday. Okay, so let's say it's A, this is memory space for B, and this is a memory space for C. Okay, so it will create all the three, and let's say this is the memory given to them. Okay, Now you all know JVM first of all creates the object, gives it an address, then goes to the class, sees all the instance variable, creates them, and also gives them the default value. And we know the default value for integer data type is 0. So I'm going to give 0 to all of them. Now, this has finished the RHS. Okay, now coming to the LHS part. We are creating a reference variable or a handle X to access this object. Now, all these days, I was just randomly creating out on the stack. Yesterday, I explained you, I just created directly on the stack. No. Now, where inside stack is getting created? Inside the activation record. Now, you see this reference variable X is being created inside the main method. It's created inside the method. So, it will be created inside the activation record of this method. So, X will be created here. Okay. And X will be holding a value. It will be holding the value 4000. And because it is holding 4000, it will be able to, point towards this object. Okay. So this is basically what is going to happen. Okay. So now it can point towards this particular object. This much will happen when this particular line finishes execution. Okay. Now, after this, when this line starts to execute, what is going to happen? Okay, this line. Now, this line, as you can see, x.add. So you're calling another method of another class using the handle. So what will it do? It will take the control from here and give the control to this particular method here. Okay, now again think about it. Don't you think we are entering a new method? So whenever we are entering a new method, we will create the activation record on the stack segment. So now above this, a new activation record will get created in the memory. Okay, now what is this activation record? It's the activation record of the add method. So I'll say activation record of add method, and the complete body of add will be present here. Now, can you see it is piling up one above another? It is like a stack. Let's say you have 5 books, you keep one above another, right? Similarly, it is like that. Hence, this memory was called as stack, because the activation records get stacked one above another. And remember, there is a beauty to it. Okay, this is a trick. Whichever activation record is at the top of the stack will get executed first. Now you notice all this time main method was the only one in the stack segment, hence it was getting executed. But as soon as a new method activation record is above it, because add activation record is now above main method, because this is at the top, will execute add method now. Okay, now as you can see, the control entered this, we created this. Now let's see, let's say this 3 lines gets executed. What will happen? We are assigning a value. So we are assigning a value to a equals to 10. So I'm going to remove the previous value and I'm going to write the new value here as 10. Okay, similarly I will remove the previous value, that is 0 of b, and I'll update it with a new value 20. And finally we have c, which is a plus b. So again, the 0 value will be updated and modified. A new value which will come and sit here is 30, that is the addition of a and b. Now when the final line, that is this particular line, executes, okay, when this line is executing, understand we are trying to print something. We are trying to print the value of c on the screen. So let's assume this is the output screen, and because currently the value of c is 30, so 30 is getting printed here. Okay, after this, is anything left? No, nothing is left in this method to execute. In other words, now the control is leaving this method. Okay, once it leaves this method, it will return back to the same place it came from. That is this particular line. Okay, now remember, once the control leaves the method, or once the method finishes the execution, what happens? This particular activation record gets deleted. Okay, now I cannot remove it completely, then you will not understand, or you will not be able to copy. So I'm going to make it in this manner so that you remember that it is no more available there. Okay, so that you can copy later or take a screenshot. At the same time, you will understand this is no more available. Okay, so it is in dash. So now assume that this is removed. Now once this is removed, again, which activation record is at the top? Main method activation record, correct? So now which method will be executing? Main method. But tell me, is anything left in the main method to execute? No, there is nothing left for me to execute in the main method. So again, from here, the control will come out and go back to the operating system. Remember, once the execution is finished, the control, one second, the control always comes back to the operating system. Okay, but again, remember, something happened, correct? If you notice, the main method activation record should get deleted because the control came out of the main method, or in other words, main method finished execution. Because it finished execution, even the main method activation record will be getting deleted. But that's not it. What I want you to focus on is, because the activation record of main method got deleted, this is no more available. That means this X value is also no more available, because that was created inside the activation record of main method. So this is no more there. In other words, this connection is no more available. That means this object is not being pointed by any reference variable. This is, orphan, you can say. Okay, no one is pointing towards this object anymore. And if you remember, yesterday I taught you, if there is an object in the heap segment and there is no reference variable pointing towards it, then that object is called as a garbage, and the garbage collector will come and remove it. So because this got deleted, this activation record, the X got deleted, and because the reference variable X got deleted, there is no one pointing towards this particular object, and hence this object becomes a garbage, and the garbage collector will remove it, and the complete memory, the stack and heap, is clear. But we got our output 30, which we wanted. So understand, in a simple 30, to get a simple 30, this much work would have happened at the background. Okay, but that is one thing to notice. Second thing I want you all to notice, I hope we all noticed this particular note which I gave here. Now this will particularly make sense. See, whenever a method is called, in other words, whenever a method starts to execute, its activation record is created on the stack segment. That happened, we saw. Similarly, whenever the control exits, or when the method finishes this execution, okay, its activation record is deleted from the stack segment. That is what we again saw, correct? That is what happened here. Not only that, I'll also point you out to one more thing. If you remember, I showed you the very first types of methods: no input, no output. See, this is a method which has no input and no output. See, what is the name of the method? Add. That was the first thing. I told you, right? Every method has four things: a name, a input, a body or statements, and a return type or output. So the name of the method is add, but if you see, there are no input. In other words, there are no parameters. Is there a body? Yes. What is the return type? Void. Void in technical term means nothing. Okay. In other words, the method has no input, the method has no output. But normally, a student or a person who's learning Java for the first time often thinks output means it should print something on it. No, that is not the output. Output of a method is when he returns some value to the calling method or the calling statement. If this method would have returned something to this particular line, a value, let's say, then we could have told, oh, the method has a output. If this particular line was sending some value to this method and he was accepting in this bracket, then we could have told, oh, the method is taking an input. But as you can see, the method is neither taking an input nor giving a output. This is a perfect example of no input, no output. Any doubts here? If not, please quickly take a screenshot. Any doubts, you can anytime unmute and ask me. Please feel free to ask anything. So there is no question, I assume, okay? Because there's a utter silence. Now, I hope this much is clear to all of us. I have shown you the execution for the same, okay? Now, let's go to the next one, that is input but no output, okay? Now, for showing that, let me first show a program. This is the program that I've written where, there's a main method where I'm creating an object of a class called as addition2. After creating the object, I'm creating two different variables, int a and int b, having value 10 and 20. Not only that, then I'm calling the method present inside this class addition2 with the reference variable. I'm telling x.add, I'm passing the value a and b. Now what will happen? This is the class. Okay, inside this class, there's a variable called as temp and method add. Now this method add actually is capturing two different values, 10 and 20. Okay, so 10 will come and sit in x, b will come and sit in y, that is 20. Then there will be addition and then it is printing. So let's see how it will actually execute at the background. But first, let us execute and see what is the value I'm getting. The output again is 30. Let's see how it is executing. I'll come to the next one here. Okay. So same program, you can watch it if you want. Okay. Now, again, same thing. There's a OS. Okay. I'm gonna write it as OS here. Okay, there's the operating system basically. So the operating system will definitely, what it will do, it will give the control to the main method. Now again, we are entering a method, so we should obviously create a activation record for the same. So I'm going to create activation record here. Now you already know it's activation of record of main method and the body should be there. So I'm no more writing it completely. I'm just giving it like this so that you understand that it will have the complete body. This much is enough. I guess this much is enough. You will understand, right, that the main method activation record and the body of the main method will be there. Okay, having a little less space to write things, hence I'm writing it in short. Hope you don't mind. Now the next thing that happens is the next line, that is we are entering the method. Inside the method, the very first line that will execute is this particular line. Again, equals to, so RHS will execute first, that is the new keyword. Again, as we all know, whenever we hit a new keyword, we actually create the object. So let's say create this object. JVM just not creates the object, it also gives the address to the object. So let's say the address for this is 5000. Now the next thing is, we have to create an object of this particular class. So I'll go to this class. I'll see what are the instance variables we have. I have only one instance variable. So I'll create that instance variable here. I'll say temp, and maybe, I'll give the memory as well. One second. So this is the memory given for temp. Now you also know JVM initialize them to the default value, and because temp is of int type, so the default value of temp is 0. This much would have happened when the RHS is executing. Coming to the LHS, we are creating a reference variable. I hope we all know the reference variable is always gonna get created inside this particular activation record. Okay, and the value inside this reference variable is 5,000, as you all expect. And because it has 5,000, it will also start pointing towards this particular object. Okay, so this much is what has happened in the background. Now understand, once it is done, the next part of the execution is the next few lines. Okay, so assume this 2 lines gets executed. So we are creating a variable a and b and assigning the value 10 and 20. But remember, because these variables are created inside a method, okay, and not outside a method, they are called as local variables and will be created inside the activation record of main method. Okay, so this is your a and this is your b. Not only that, remember, if I explained you, if you remember what I explained, I told you a local variable will never be initialized to default value by JVM. So 0 and 0 will not be there. It will never be initialized to default value. You as a programmer have to initialize it. And as you can see, I did not just create them, I initialized them at the same point of time. So I'll give here as 10 and here as 20. Okay, now the next line which is going to execute is this particular line, x dot add, and I'm passing a and b. So what is happening is, actually I'm doing is I'm calling this method here. Okay, and not just calling, I'm also passing 2 different values. I'm passing a, which is equals to 10, and b, which is equals to 20 here. Okay, remember that. And remember, because a is the first one that you passed, so a value will come and sit in x, whereas b you have passed in second, so y will be holding the value of b, that is 20. So whichever you have arranged here, same arrangement will come and sit here. Okay, now again we're entering a new method, so you know what happens, a new activation records get created. And also, whichever activation record is at the top of the stack, that is the activation record which is going to get executed at that particular point of time. So the add method, which is which is having integer type x comma integer type y, will get executed now. Okay, this is the method which is going to get executed now. Now inside this, okay, if you notice there are 2 lines. So let us assume we are executing the very first line here. Okay, and the very first line says, please add the value of x plus y and store it into temp. So the value of x is nothing but 10. The value of okay, one more thing, I'm really sorry, I forgot. Don't you think once we entered this method, we have created the activation record, but at the same time we're creating 2 different variables, x and y, and they are local variables. Now you might argue with me saying, sir, you told local variables are the variables which are created inside a method. Can you see the method signature starts from here, and this is the method signature. Don't you think it's a part of the method? So it is inside the method. We consider it inside the method. So we are creating 2 local variables here. So I'm going to create 2 local variables here, that is x and y. Okay, and both the local variables will not be initialized to default value by JVM, as we all know. So we as a programmer directly initialize them to 10 and 20, because when we pass the data 10, and 20 it came and sat here. Okay, this much would have happened. Now when you execute this line, temp equals to x plus y. So as you can see, the value of x and y is 10 and 20. So the value which will come and sit in temp is nothing but 30. So 30 is coming and sitting here. Now the next line is this one where we are printing some data. So this line once executed, we're gonna get the output 30 on the monitor because temp current value is 30. So 30 will come and sit in the output. Once done, you can see there is nothing left for me to execute in this method. So the control from here will return back to the same line. But not only that, we all know what's the next thing that is going to happen. This activation record is going to get deleted. Okay, it's going to get deleted from here. Now once this gets deleted, the value x and y is also getting deleted with it. Okay, so there's no more x and y available. Plus, if you notice, main method is at the top now again, because there is no add method in the activation record of add method is no more available. So main method activation record is at the top, but again we have nothing to execute in the main method as well. So the control from here exits and goes back to the operating system. Not only that, you also know what happens to the activation record of main method. It gets deleted. And once the activation record of main method gets deleted, I hope you all already know that the value or the variable x, the variable a, the variable b all got deleted. And because they all got deleted now, they are no more available. This pointer is also no more available, or this cursor which was pointing towards it is no more available. So the reference variable is no more available. Nothing is pointing towards this object. The object becomes garbage and it will be deleted by the garbage collector. We got our output 30, and here is your method which is accepting our input but is returning nothing, no return type, that is void. This is your second method type, input but no output. Any doubts, people? Ask me, or
Yes,
please.
sir.
Yeah.
Sir, in here for the A and B, we have already declared the int, as their int. Then again, why we are declaring as int in the for x and y
So
in
you
the
are
add?
telling her that I have declared A and B here, so I am declaring it here, correct?
Yes, sir. We have already declared a and b as integer. Then again, we are declaring x and y as integer y.
So how can I explain this? Okay, tell me, you declared the variable A as integer, correct?
Yes, sir.
Yes. Tell me, if I just think about it, okay, what if I erase this? Can you tell me what is the data type of X?
Somehow a will store in x also.
Okay, I understood that A will come and sit in X, but let's say, okay, you are writing this part of the program, okay, and I am writing this part of the program, okay. I told you that, see, I'm sending you the value of A, and I didn't tell you the data type, okay. How will you know by seeing this? Will you understand?
But here we have already declared it as int now, sir.
You know it is. That's what I'm trying to convey you. See, you as a human, okay, as a human brain, we can understand, okay, A is of integer type and I'm sending integer data, so x should also be of integer type. But our programming languages are not that updated, they're not that modified, so they doesn't know that x should be of integer type. You have to mention, and the reason behind it is, uh, okay, I cannot explain it to you. Okay, just wait for two more examples and they'll understand why we should define it here. If you don't define it here, okay, first of all, the programming language doesn't understand what kind of data this should take as input. Secondly, method overriding would have not been possible. It's one of the concepts of Java. Okay, so that is also one of the reason why this is declared. And also see, let's say I would have written this add method to add to integer. But what if you are sending two values here, which is a and b, and the a is of double type and b is of float type? Will you agree this method should not accept it? Hello?
Hello, sir. Yes.
Yeah, reply. Assume, okay, chalo, assume it. This a is of double type. I'm writing d here, okay? This is of double type. And
Okay.
let's assume this is of int type. Now I'm sending a and b. Now what is your expectation? That this should be of double type?
Yes, sir.
Yeah, but I have created this int type, so this should not work. So that is what my thought process is. So we should always define here, okay, what data
Okay,
type
sir.
we are trying to accept. So the method knows, right, that okay, I'm gonna accept integer and integer. So any other value, if you send, it will cause you a problem. And that is very much important. A method should not accept any other value other than what it is accept, or what it is thinking to accept. Okay, you will know, understand its more value when we move ahead.
Yes, sir.
Okay. Any other doubts, people?
No, sir.
Great. Please take a quick screenshot.
Done, sir.
Okay. So I'm going to jump to the third program now. And I'm going to speed up the process a little because you've already seen me. Same thing, a class addition 3 object is getting created. I'm calling the method x.add. Actually, I'm calling the method add, which is I'm using the x reference variable to do it. And I'm passing the value 10 and 20 directly. Okay. And this is going to get stored here. X and Y is getting added to temp, and I'm not printing the value of temp in this particular method. Rather, I'm returning the value. So how do you return the value? By writing the keyword return and the variable name of the value here. So I've return temp. So the value of temp will be returned. And what kind of a data am I returning from here? Integer. Hence, I'm writing here as int. See, the return type this time is int, so that the program understands that I'm trying to return an integer value. Now, where will it come and sit? It will come and sit in this place. Okay. As you all know that temp will actually hold 30. Okay. So what is actually happening is 30 will come and sit here. Okay. When it's executing, that is what happens at the background. Okay. And 30 will be stored into res. And then I'm trying to print res. So I'm going to print 30 as an output. Okay. And if you see, this is a particular method where there is an input as well as there is a output. Okay, I'm not going to execute this program. I want you all to take a screenshot of this and try to execute it yourself. Okay, think about it, how it will work, and how the execution will happen. What should be created? What are the local variables? Should x and y be created inside the activation record of add? Should temp be created inside activation record or inside the object? Where should res be created? Okay, all these things you should decide, you should draw. And I want you to draw something like this actually. Okay, and show me what is the control flow. Okay, maybe tomorrow when I have some time, I'll execute this and I'll show you how it will work. But tomorrow I want to move ahead with the topic. Okay, so if you want, you can take a screenshot of this one. If you want, you can take a screenshot of that one. Choice is yours. Okay, take a screenshot quickly. I hope the thought process is clear, that there's an input to the method, there's an output to the method this time. Okay, I'm no more printing the value inside the method. Rather, I'm returning the value, which will come and be stored into res, and then res will print the data. We're printing the value of res. Try it out. If you're not able to do it, anyways, I'm here to help you out. Okay, done with the screenshot?
Yes, sir.
Yes,
Yes,
sir.
sir.
Great. So next one is this one here. Okay, it's pretty simple, very simple. No input but output. Okay, so what I'm doing here, I'm creating an object of class addition 4. Okay, I'm creating a local variable res. Then I'm telling res equals to x dot add. So the control from this line will come to this method here. Okay, we already have 3 instance variable a, b, and c. So a has the value 10, 20, and c is addition of both. Now after adding and storing in c, I'm returning it. I'm returning the value of c from here. So in other words, I'm returning the value 30 from here, and it's an integer value. Hence the return type of the method is int. So from here, from this particular line, the control will come and sit back here, and it will change this to 30, and 30 will come and sit in rest, and that is what will get printed. Just so you know, one return type I wanted to show. I'll execute this program. It's the answer is 30 as same. I'll just show you this one. Okay, I'll quickly show you this one so that we don't fall back on time. 1 second. This one is your assignment. This one I'll do. Okay, so I'm cutting it short. I'm making it a little fast. OS is there. Try to catch up. Pay attention. Okay, control enters main method. Okay, so activation record gets created basically of main method. Once the main method activation record is created, we are going to create an object that is x equals to this. So I'm going to create an object on the right hand side for me, because that's the very first thing to do. Let's say this is the object I've created. Some address I'll give. Let's say I'm giving the address as 4000. Okay, so I'll see this class has 3 reference variables. So I'll create a. It has 3 instance variable. Sorry. So it has 3, that is a, b, and c. Once created, I'll give some memory for them inside the object. And we also know that not only just the memory, it will be also allocated with the default value. So the default value happens to be 0 for integer. So it will have 0, it will have 0, and it will have 0. Okay. Now, as you can see, the right hand side is done. Left hand side x, it's a reference variable. Okay, so the reference and the local variables gets created inside this particular memory. So I'm going to create x here, and not only that, I will give it some space, and it will store the value 4000, and it's going to start pointing towards this particular object here. Okay, once it starts pointing, we'll go to the next line. I'm creating a local variable res. Okay, so I'm going to create it here, res. Because it's a local variable, it will not be initialized to its default value by JVM. So it's going to be blank. I, as a programmer, should initialize it. Okay, so we have finished these 2 lines. We are in this particular line. So here it's telling res equals to x dot add. So the control from here will come and enter this method here. So we are again entering a new method, new activation record gets created, as we all know. Now the next thing, it's the add method activation record, the complete body. Now we are not accepting any input here, so no local variables is getting created. So directly we will execute this lines. Okay, so once this 3 lines gets executed, basically what happens is it's updating the value here. So the value of a will be updated, the value of b will be updated, and the value of c will also get updated. The value of a is updated with 10, value of b is updated with 20, a value of c is updated with 30. Okay, because c equals to a plus b. Now finally you're telling return c. So the value of c here is 30. So 30 is what is returned to this particular line here. Okay, so I'm just going to write it here that 30 is getting returned so that you understand. So what comes and sit here in place of x dot add is 30. So 30 will be given to the value, 30 is the value given to res. So 30 will come and sit here. Okay, Now what? Now the next line executes, that is this particular one where we are printing the value. So basically we are getting 30 in the output screen because we're printing it. Once done, because we came out of the add, we forgot to remove it. So this add method activation record got deleted, obviously. And because it got deleted, main method came up and we printed the output. I hope you know that much. And because we are also coming out of the main method and giving the control back to our operating system, even this one here gets deleted. Okay. So this one also gets deleted. Because this gets deleted, the variable x and the variable res gets deleted. The pointing got deleted. This object became garbage and garbage collector deleted it. So this is what happens. Quickly take a screenshot of this one also. But I want the launch 3 program. Okay, the third one where there was input also output, which you took a blank screenshot of. Okay, I want you all to finish it yourself. Think about it, very easy. It will help you understand. Just remember, local variable and reference variable gets created inside the activation record. No default values are assigned to it. All the instance variables are created inside the object and default values are assigned to it. Okay. I hope you have taken a quick screenshot.
Yes, sir.
Great. So today's last concept that I want to explain you all is, it's a very simple concept, method overloading. It's a proper, or an let me say it's a appropriate day to explain method overloading, because you just learned about different kinds of methods that we have. Okay, just give me 1 microsecond and I'll finish it off. Okay, so I hope you have already taken this one as well. I'm going to remove this, not required. Now, what is method overloading? Okay, we'll come to that later. I hope all of us have in our life at least heard of C language once. Okay, in C language, remember, there is nothing called as a class. Okay, and the method, there is no method, they are functions. Okay, now watch it and understand. Inside a C program, forget about whatever is written on the screen, just hear me. Okay, in a C language, you as a programmer can create n number of functions. Okay, you can create multiple functions for doing multiple jobs. Okay, that is the profit, that is the advantage of C language. Previous to C language, whatever there was, programming languages you had IVPL, IVCL, you had B, and so many other languages we had. In all those programming languages, we could write only one method. In the complete program, there will be only one method or one function, that's all. But from C language, okay, the inventor of C language was Dennis Ritchie. Dennis Ritchie came with a very thought process that, okay, let us not write all the statements, all our logic inside a single method or function. Let us divide it into different parts. And he was the first one who came up to write multiple functions inside a single program. And that is what you're seeing here in the program written in the screen. We are having 5 different add methods doing 5 different jobs. The very first one here is adding x and y, which is both integer. Add 2 is adding integer with float. Third is adding float with float. It is adding float with integer. It is adding integer, float, and double. You can see this, right? We have multiple methods doing multiple jobs. So it was the advantage of C language. But at the same time, slowly, the developers started to analyze that this is not just an advantage, but also a disadvantage. You might ask me why. Dennis Ritchie told, yes, you can write multiple methods or functions inside my language, but one thing you should keep in mind, that all the functions should have a different name. If you notice, I've written add 1, add 2, add 3, add 4, add 5. Now, how can this be a trouble, you might ask me? Now, let's say this program which you are seeing, this part, okay, this box is written by developer 1, and this part is been written by developer 2. I hope you understand. In a company, in actual project implementation, okay, while it is happening, you won't be able to code the complete project yourself. Okay, the complete project or the complete application you're building will be divided into subcategories, and each team will be handling a part of the code. Okay, let's assume dev1 is one team, dev2 is another team. So this team work is to write multiple add methods. Because they cannot name it same, they have named it as add1, add2, add3, add4, add5. Now this team who has to write the main method is actually gonna use these methods, but they have never seen the code. Okay, they have never seen what the dev1 has coded, but they were given a sheet, okay, where they were told that, see, add1 will add this much, add2 will do this, add3 will do this. So that was a detailed message they got from dev1 team. Now you think, let's say we all are the people who are working for dev2 or the developer 2 team. Now think, the life is so much difficult for us. Okay, now if I have to add integer with integer, that is a and b, I have to call add1. Now, let's say I have to add an integer, a float, and a double. I have to call add5. So I should remember which are the methods which are adding two integer. What is the method name which is adding an integer, a float, and a double? So understand, that was the trouble here. As a developer, I should learn and remember all the method names and their particular functions. That was the problem. Okay, and it is difficult. As of now, if you notice, we only have 5 methods. Okay, but in an actual project implementation, there could be thousands of methods, and remembering all of them is not that simple. Is there a doubt? Okay, so remembering all the methods will be very, very difficult. So hence this was became a disadvantage. Then that's it. That's the exact thing what I've written here. Any number of functions can be created. However, it's a rule in C language that two functions cannot have the same name. This creates a trouble for the developers to remember. Sorry, don't mind the remember spelling. I would have mistyped it. Remember multiple function names. So as a C developer, the problem was I should remember all the methods, okay, and their functions, and that was a trouble. That is what James Gosling overcome in Java. Java was invented by James Gosling, and he came up with this thought process. Let me make this simplified. I will allow my developers to write multiple methods with the same name. Okay, take a quick screenshot of this. I'll make some changes on it because, okay, take a quick screenshot. I hope you all took it. Now, notice here, if, okay, James Gosling allows, let's say it's not C anymore, it's Java. And James Gosling is telling, you can have multiple methods with the same name. So don't you think I can have all these methods with the same name, add? Okay. Now, if that is the scenario, tell me, if I have to add to integer, which method should I call? Add. If I have to add an integer, a float, and a double, which method should I call? Add. Okay. That is the beauty of Java. Java overcome this problem. He told you can write multiple add methods within the same class, because we write all the methods inside a class. He told you write all the methods are same, no problem. Okay, so now as a developer, see, let them develop 2000 3000 methods, doesn't matter, because when I'm working for dev2, I know which method to call. I'll call add method. I need not remember multiple names. I should remember only one name, add, because all of the names are add. But with this came a problem. Now tell me, the compiler who is compiling and JVM who is executing a program, how will they know which add method you are calling? That was the problem. Now, how did James Gosling resolve it is the next question. Now, let me take you to this particular slide. Now, I know there is a lot of things into this particular slide, but I want you to not see anything. Just don't see anything. Whatever I'm speaking, just see that, okay? Let's come to the note 1. Let us read the notes and then we'll go again to the explanation. In Java, multiple methods within a single class can have the same name. Okay, so if you see here, now come here, watch this class demo. Okay, you can see the beginning of the class, you can see the ending of the class. Okay, inside this class you can see multiple methods having the same. Okay, I forgot to write the name add here. I'm really sorry. Please attach this here. Okay, I had written it in a hurry, so the method name only is missing here. The method name in all this part will be add. I'll just add it here quickly. Okay, now if you notice, all the method names are add. So the very first note should be clear. In Java, multiple methods within a single class can have the same name. Second, creating multiple methods within a single class having the same name is called as method overloading. So basically, what is method overloading? In Java, method overloading refers to the process of writing multiple methods with the same name within a single class. This way of writing methods is called as method overloading. So I can say, as a developer in class demo, I have overloaded the method add. Okay, in company when you go, okay, people will ask you in this way, hey, is the add method overloaded? You will say yes, the add method is overloaded. They might ask, okay, how many overloading have you done? You will say, I have done 6 overloading. In other words, I've written 6 different methods to overload the add method. In other words, you have written 6 add methods inside your demo class. Okay, that's how they will talk in the company. So what is method overloading? It is a process of writing multiple methods with the same name inside a single class. I hope the point 2 is clear. Coming to point 3, what is the advantage of method overloading? Easy to use, or the ease of use, you can say. Again, same thing. Let's say this is a developer, okay? This is developer 1 and this is developer 2. So developer 1 codes anything, doesn't matter. Developer 2 will only remember one name, that is add, and he can easily call the method using it. But what is the disadvantage here? Point number 4. The disadvantage of method overloading is that it is time consuming for the compiler to bind the method call with the method body. Okay, I'll tell you what is this method call and method body. Okay, it is nothing. Okay, it's very simply telling you that it takes time for the compiler to bind. Bind means connect. Okay, the method call with the method body. Here, if you notice in this particular part where my cursor is now, I'm calling h.add method and I'm passing a and b, which is of integer type. So this place, I'm actually calling this method here. So for the compiler I'm calling a method here, and this is the method body. Okay, the very first method here. So to attach this method call to this okay, I'll show you in this method. To attach this method call to this particular method here, okay, the compiler will take some time. And that is what I'm mentioning it here, that the time consuming, it's a time consuming process for the compiler to bind the method call with the method body. But it doesn't matter. It's still, the advantage is more benefit. We need not remember multiple method names. So we still will use it. But how come the compiler comes to know that, when I'm writing this particular method here, I mean calling this method, it is this add method. How does he come to know that? There are so many add methods. I could be calling this one. How does he resolves the call? Or in other words, how does he resolves the conflict? That is only 0.5. The name, okay, all the names are same. So we call it as a name conflict. So the name conflict of method overloading is overcome by the compiler in the following ways. Okay, the very first one is by using the number of parameters. Now notice here, when I created the object of demo class and the reference variable h, I'm saying h.add. Because I'm calling the add method, the compiler will see, oh, there are 6 add methods. Okay, so there is a conflict of name. So he's going to use the very first technique called using the number of parameters. So you'll see how many parameters are there, a and b. Now if you see, these two have 3 parameters, x, y, and z. So this will be deleted. Not deleted, I mean this will not be used. So we are left with 4 methods. Okay, but still this technique did not resolve the conflict. We are still left with 4 different methods. So the compiler will use the second technique using the data type of the parameter. Now see, a is of integer type, b is also of integer type. So you will see now in these 4 methods, which is that method which is accepting 2 integers. Now notice it is accepting integer y and integer x. So this is the perfect method. Okay, because others are integer float, integer double, float int, but this is the one which is accepting integer and integer, and hence this is the perfect one. I hope the person who was asking me that question, sir, why are we writing integer here? This is one of the reasons to make use of this in the method overloading concept. See, because it was resolved in second parameter only, third was never used. Now let's say I'm executing this one here. Okay, add a comma y comma m. What is happening? Again, there's a name conflict. There are so many add methods. So the very first one will be used using the number of parameters. It is sending 3 parameters as input from here. So you can see there are only 2 of them which is accepting 3. So rest all will not be used. But still there are 2 methods. How will we resolve it? By using the second technique, using the data types of the parameter. What are the data types? A is of integer type, y is of float type, m is of double type. So I want a method which is accepting a integer, a float, and a double. Can you see there's only one method which is accepting integer, double, and float. Again, the compiler resolved it. But again, we never use the third one. So let's use the last one. Here I'm calling an add method and I'm passing z, which is of float type, and c, which is of integer type. Now, which will this call? There are so many add methods. Again, using the very first technique here, number of parameters. So it is sending 2 parameters as input. So this 2 will not be used. We only are left with this 4. Okay. Now, second one, using data types of the parameters. So z is of float type, c is of integer type. So I'm going to use a method which is accepting 2 parameters, and one of them is float, one of them is integer. Can you see this is one of them, but again this is one of them. Again, there are 2 methods which is accepting 2 different parameters, and one of them is float and one of them is integer. So even the second technique is not helping us resolve it. We still have 2 methods. Which one to select? That is the exact time when the third one comes into picture, using the order of the data type. Now see, I'm sending z first. Z is of what type? Float. C is of what type? Integer. So I'm sending float first and then integer. Now notice this is one where integer is coming first and then float. So I'm not gonna use this one. Rather, this is the one I will be using because it is accepting float first and then integer. So the order of the data type is what matters here. Okay. Now you will say, sir, what if float and x was float here and this was integer? Don't you think then this two becomes the same method? and two methods with the same name, same number of parameters, same order of data type of the parameter is not allowed. You cannot write two same methods. What is that use? Correct? So at least the order will be different. See, it is also returning float. This is also returning float. Both of the name is add. One is integer, one is float. But here, first one is integer, and here the second one is integer. Okay, so this is how the compiler resolves the problem of name conflict. Because it is a little bit time consuming, okay, that is the disadvantage. But this sixth point is very, very important. Okay, this will be the question that will be asked to you in the interview, and I want all of you to pay attention. Okay, method overloading helps to promote virtual polymorphism. Now, what do you mean by this word called as virtual polymorphism? Okay, let me just copy this word from here. Now, what do you mean by virtual polymorphism? I'll just take the word here, okay, and try to explain you. Now, I'll divide the word into two different parts, first of all, okay? Let's us divide it in two different parts. So the first part is saying virtual. Virtual means something which is false. So I'm going to write it in a different color. Something which is false. And polymorphism, okay? This means one into many relationship, okay? If you break the word, I'm talking about something which is false, and I'm talking about which is having one to many relationship. Now, why method overloading is called as virtual polymorphism? Okay. Now, I want you to concentrate on this box here. Okay. Now, I told you this is one developer. Okay. This is being developed by one. Class demo is written by first developer. Class launch is written by second developer. Now, understand, think about it. Okay. As a developer too, okay, who is writing launch class, don't you think I don't know how many add methods the developer one has written? I don't know. He just told me, hey, developer two, if you want to add two integer, you can call my method add. He told, if you want to add one integer, one float, you can call my method add. If you want to add an integer, a double and a float, call my method add. So as a developer two, what I'm thinking, oh, what a wonderful developer one is. He has written a add method which can add integer with an integer. It can add an integer with float. It can add an integer with double and float. So he has written such a add method who can do multiple jobs. But tell me, is that the reality? No, right? That is not the reality. Actually, developer one has not written one add method, rather he has written multiple add methods. Because he kept the name same, developer two is thinking, oh, developer one has written only one add method who is doing multiple jobs. But that is not real. The reality is that he has written multiple add methods, and each add method is doing only one single job. Like, see, here the add method is adding integer. He cannot do anything else. He cannot add an integer and a double. Here he is adding integer and float. This add method will only add integer and float only. No other job he can do. So remember, this false illusion that developer 2 is having, that there's only one add method and that add method is doing multiple jobs. This illusion only is called as virtual polymorphism. The developer 2 thinks that one method is doing multiple jobs, but it is one method doing one job. And that is what is written here. Sometimes they ask this question, what is overloaded in method overloading? Remember, it's a trick question. Okay, what is overloaded in method overloading? Don't tell, oh, sir, method is only overloaded. No, nothing. Can you see any of the method overloaded or too much work? No. Every method is doing only one job. So the answer for this question is, in method overloading, nothing is overloaded. It is just an illusion which the user has that one method is performing many tasks. But in reality, one method is only performing one task. Hence, it is considered to be virtual polymorphism. Virtual means false, false reality. In other words, false one-to-many relationship. I hope This is clear, and with this, I end your topic methods and method overloading. Any doubt, you can ask me. And please take a screenshot of this one.
Excuse me, sir.
Yeah.
Why you have written that system P out println?
I'm really sorry. I was typing late night, so I by mistakenly would have misprinted it. Please.
It's okay. I thought it has something new.
No. It's system.out.println. While typing, I would have missed it. Because you told, I just saw I haven't closed the bracket of main method as well. So before someone asks it, I'll just close it here. Okay. It is system only. Okay. All of you have taken a screenshot?
Yes, sir.
Yes, sir.
Great. So I hope you have no doubt. If you have a doubt, read it, take time, ask me right now. If not, then I'll give you time, read, revise it, come tomorrow. Tomorrow you can ask me a question. Okay. And also tomorrow solve that question, right? Which I gave you. Input and output. Solve it. If you
Yes.
are not able to do it, ask me then. Okay. Anyone has any doubt? Okay, I'll take it as a no. So with this, people, I have covered this topic as well. So we are done with method overloading. Okay, so it's day 6. We have finished it. Others, don't worry. I know you're seeing this list. Don't be worried. So we have covered this much actually before you all joined. So this much will be taken care of. Don't be worried. It's not that complicated. It's basics. That's all. But it's required. Hence, we'll give you a backup for this. Okay. Tomorrow, don't miss the class at any. Even if you are dying, please don't miss the class, because tomorrow we are starting with strings. Because strings is one of the very important concepts, and question will come from string in any interview go, and it is related to Java. It will definitely come. Okay. So that's it for today, guys. I hope you enjoyed and you have learned something new today. And
Excuse me, sir.
yeah.
Sir, actually, I want. Did you record yesterday's session, sir?
No, I'm really sorry, Ashish. I did not do so. Actually, I was asked to, but because I was asked in a message and I didn't see it while I was teaching, so I
Actually, I wanted once again, sir, yesterday's topic.
is there any doubt, or you didn't attend?
I attended, sir, but still I wanted to.
Listen to it.
Yes.
Okay. Anyways, from here we are recording it, so you can do what? For those